So now we'll finish kinematics, and we'll finish with angular kinematics. So remember, typically human motion, there's the linear side and the angular side, and merged together we have general motion, which is basically how we move around the world. So in the linear we saw displacement, velocity, and acceleration, and we'll see the same for angular kinematics. Angular rotation in degrees or radians, angular velocity in degrees per second, and angular acceleration in degrees per second squared. So here are the equations for each. So the rotational angles we represent with the theta. Here's the change in degrees over time, gives you angular velocity. Change in angular velocity over time gives you angular acceleration. Just so you're aware of what radians are a unit based on the circle and using pi so that you can get a decimal basically to do more mathematical equations. Typically we'll use degrees. We kind of think in degrees in the clinical or applied world, but just know that radians do exist. All right, so how do we figure out the angular motion? You're going to do that a lot in Dartfish. You probably already have. Way back in the day, when video was in its infancy, or not infancy, but early on, you would have a darkened room. You would say, put the video camera to the sagittal or the side view, turn out the lights, and then you'd have these reflective markers. So it was easy to track the joint motions. And you basically make the knee joint by connecting the dots. So between the hip and the knee and the ankle, that angle, or those two segments, make the knee joint that flexes and extends. And then you can get this graphical view of it during the gait cycle or the running cycle, and you see flexion is going positive, so the knee flexes, extends, extends. All right, some rules for looking at these rotational graphs. Maximum velocity occurs at mid-motion, and we saw that in the linear kinematics lecture when we had almost like the shuttle run, people running back and forth. If you go from point to point, your max velocity is midway. Zero velocity occurs at a change in direction. So if you flex your elbow and then extend your elbow, at that precise moment when you change from flexion to extension, you have zero velocity. Because to change direction, you have to stop and turn around. Maximum acceleration occurs to initiate the movement. And again, I like to think of acceleration as a force. So when I'm starting to flex my elbow, I generate a force which creates a flexor acceleration. Zero acceleration occurs at the point of constant velocity or maximum velocity. And we'll see that a little later. All right, so let's look at these again. So here you have a position curve, maybe flexion and extension. Okay, so here we have a general curve, a position curve, and then a velocity curve. And so let's just look at what's going on here. So you go from position 1 to some sort of endpoint, and then you come back down to 0. So maybe flex, extend, or flex and go back to the starting point. So max velocity, this is your velocity, max velocity, so the peak occurs mid-motion. So that works out. Now zero velocity, so when your zero graph comes back down to 0, that occurs when you're changing directions. Right? So this is going in the positive direction, and then you turn around and you go back in the negative direction. We won't worry about acceleration because we don't have it on this curve. Okay, but